Hi, this is the new section, Neural Network Learning and Data Processing. We start with the first video, Hyperparameter Selection and Tuning. Let's begin by learning rates and learning rate schedulers. It helps to avoid local optimas when using smaller learning rates. However, it often takes longer to converge. What can help shorten the training time is using a warm-up period. In this period, we can use a bigger learning rate for the first few epochs. After a certain number of epochs, we can decrease the learning rate. It's even possible to decrease the learning rate after each step, but this is not recommended because you might be better off using a different optimizer instead. In theory, when the learning rate is too big during the warm-up period, it can be the case that you won't be able to reach the global optima at all. Let's demonstrate how to set a custom learning rate scheduler with Keras. Let's start with importing all the libraries. Next, we will load and pre-process the data. We can set the learning rate using these lines of code. Let's add our custom function to the callbacks list. We can now define and compile our model using this line of code. Finally, we will start the training. You will notice that the learning rate follows the set schedule. Training process will take some time. The training process may consume some of your time. Next, we add dropouts to prevent overfitting. We start by importing all libraries. Next, we will load the CFAR10 dataset and pre-process it. To monitor training and prevent overfitting, we introduce callbacks using this block of code. Next, we will define our model architecture and compile our model using these lines of code. Now, we will start the training using these lines of code. Now, let's add dropouts to our model architecture. We do this after each convolutional block and after the fully connected layer. Let's start training from scratch again. Now, we will plot the training and validation accuracy of our model without dropout. We can see that the model clearly overfits on the training data. Finally, the training and validation accuracy of our model with dropouts. Now, we can see that thanks to the dropouts, our model is able to generalize better and it doesn't overfit on the training data so much. However, there is still room for improvement. Lastly, we make a model more robust with data augmentation. A popular method to boost the performance of a network from computer vision tasks is to add data augmentation. By using data augmentation during training time, you can increase the size of the training set. As a consequence, you make your model more robust to slight variations in the training data. In this video, we will be using Keras and its image data generator for data augmentation. We start by importing all libraries as usual. We will then load and pre-process the training and validation data. Next, we will define our model architecture using these lines of code. Next, we will define the Atom optimizer and compile our model using this code snippet. In Keras, we can use image data generator to easily set image augmentations using these lines of code. Next, we will set our callback functions. And finally, we will start training our model. The training process will take some time to execute.